Good morning, Year 11. I'm sorry I'm not here to do your lesson today, but I hope that you'll be able to work through this video and to be able to get as much from this video as you would with myself in class. If there's anything that you don't understand, then obviously you do need to email me and I'll get back in touch with you. And there's also a small quiz at the end of this. Okay, so let's get started with the lesson. So here's your spaced retrieval. Spend about 3 minutes on it. So pause now, complete the spaced retrieval, and then restart the video when you need to go on to check your answers. So self-assessing, here are the answers to those questions. Again, pause the video whilst you self-assess and use a green pen to make sure you can see where your corrections are, and then move on. Okay, so today we're going to be learning about equilibria still, but how temperature will change the equilibria. So if we've got a dynamic system at equilibrium, then if we stress it by changing the temperature, then how will that equilibrium respond? So we're going to be looking specifically at the temperature, the equilibrium, and the yield. And we need to be able to start to predict which way our reactions go. So these are tend to be higher tier questions, and these are where you can pick up the 7, 8 and 9 level marks. So just to go through Le Chatelier's principle, if you increase the temperature, then the system will try to reduce it. If you increase the concentration, the system or the reaction will try to get rid of the reactants if it's the reactants you've increased. So it'll try and decrease the concentration of whatever it is you've increased. If you increase the pressure, then the system will try to decrease the pressure by moving to the side that's got the least number of molecules. We're going to look at temperature. So reversible reactions can be exothermic in one direction, but it does mean they're going to be endothermic in the other direction by exactly the same amount. So if we have an exothermic process and we increase the temperature, the system is going to try and want to decrease that temperature. So the yield of our product is going to decrease because it's going to send the reaction in the opposite direction. Similarly, if we've got an exothermic process and we reduce the temperature, the system wants to increase it again, so it will favour the exothermic process, and if that's the forward direction, you will get an increase in yield. Okay, so you can read the information on there, so you can pause and read that. Once you've done that, we can move on. So here's an example. This is sulfur dioxide reacting with oxygen to create sulfur trioxide. Now it's exothermic in the forward direction, which means it has to be endothermic in the backward direction, in the reverse direction. How do we know that? Well, the delta H, the changing energy, tells us, and we can see here that the delta H has a negative value, negative 278 kilojoules per mole. And because it's negative, we know from previous lessons that that must mean that that forward direction is exothermic. It's giving out energy to the surroundings, which means the reverse direction has to be endothermic by exactly the same amount. So to make it a little bit easier, I always think of an exothermic, whichever direction is the exothermic process. One of the products has got to be heat because that's what we're giving out, energy. So one of the products is energy. So this is where I like to think of how to think of these exo and endothermic processes. So what happens then when the temperature is increased? So if the temperature is increased, we would like to use the information in this equilibrium to predict. So if the temperature is increased, the reaction wants to counteract the change. It wants to reduce the energy. So it doesn't want to be kicking out energy any more energy, because it's already, it's already producing a lot of energy. So it's going to favour the reverse direction. So it's going to want to absorb that energy that's being put into the reaction, absorb it and reduce the temperature, and it will favour the endothermic process, so it will go in the backward direction. So this is where I've said the reaction already produces energy. We know that because it's exothermic. So to put more energy in just disturbs the equilibrium that we've had, and the system wants to oppose the change. So the system will try to absorb all that extra heat energy that's been added in order to reduce the temperature. And when it does that, the reaction will favour the backwards direction, so more reactants are produced. And if more reactants are produced, it means that our yield of sulfur trioxide will decrease, because that's going to decompose back into the reactants. Pause the slide here if you need to just go through that information again to make it crystal clear in your mind. Otherwise, carry on. So changes in temperature then. So we'll look at a different system. So here we've got nitrogen dioxide going to dinitrogen tetroxide. This is an exothermic process. How do we know that? The delta H is negative. So it gets hot as you go in the forward direction. So if you were to feel the test tube or the reaction vessel that it was in the forward direction, it would feel like it was getting hot. If it goes in the backwards direction, it starts to get cold. The energy starts to be absorbed in order to break up the dinitrogen tetroxide and decompose it back to its starter materials. So that will feel cool. If it's going in the backwards direction, it will feel cooler to the touch. So the hotter the reaction is, the more energy that you're putting in, the more likely it is that the reaction will favour the endothermic direction. So you put more energy in, the system wants to remove that energy, and to do so it will have to absorb it and go in the reverse direction, or go in the direction of the endothermic process. So here's two questions. If we increase the temperature, what will happen to the yield? Which way will the equilibrium shift? So you'll need to answer that. And if we decrease the temperature, what will happen to the yield? Which way will the equilibrium shift? Again, pause the video, answer those questions, and then you can move on to the next slide in order to self-assess. So pause for as long as you need to answer the questions. Okay, so how did you do then? If you increase the temperature, it'll favour the endothermic direction, which reduces the temperature. So this means the yield of dinitrogen tetroxide will decrease. And if you decrease the temperature, it'll favour the exothermic direction, which increases the temperature. So this means the yield of dinitrogen tetroxide will increase. Okay, so you may need to pause the video again. You may need to go back and go through the previous question, and then come back and read through these answers. Once you've done that, carry on. Okay, so let's look at what we've learnt so far. So increasing the temperature of a dynamic equilibrium makes the reaction go in the endothermic direction to reduce the temperature. Decreasing the temperature makes the reaction go in the exothermic direction in order to increase the temperature. So here we've got a system A plus B goes to C. It has a delta H of minus 100 kilojoules per mole. So what does the delta H of minus 100 tell you about the forward reaction? And if I heat up this reaction, what will the equilibrium move to the left or to the right? Okay, so pause the video and answer those questions. Once you're done, we can move on. Okay, so how did you do then? So a negative enthalpy means that the forward reaction is exothermic. Well done if you got that. And the forward reaction is exothermic, so by increasing the temperature, the equilibrium is going to be shifted to the left, and that's in the reverse direction. So in the direction of the endothermic direction, in endothermic reaction, and that has the effect of decreasing the temperature. Okay, so now let's have a look at catalysts. How do catalysts affect our equilibrium? We know that they do have an effect on reactions. Well, the thing with a catalyst is it doesn't affect the equilibrium position at all. Once the system is at equilibrium, it's at equilibrium. The catalyst doesn't have an effect on it, but what it does mean is that the equilibrium, you can get to the equilibrium quicker. So a catalyst allows a reaction to go faster because it provides an alternative reaction pathway. It lowers the activation energy. So in this case, we'll just get to equilibrium quicker if we have a catalyst. So the catalyst speeds up the rate of the forward reaction and the rate of the backward reaction the same amount. So equilibrium is achieved a little bit quicker. Okay, so here's an exam question. So pause the video and answer the exam question. It's on catalysts, and then once you've done that, have a look at the answer. Okay, so here's the answers. So you can check those. The catalyst has no effect on the change, but what it does, it increases the rate or the speed of the forward and backward reaction equally or by the same amount. You do have to mention the yield. So you have, it says if no reference to the yield, you could still score 2 by saying it's by the equal amount. So it increases the rate by equal amount. Okay. So let's move on. So these are some questions that you can do. I'll leave you to read those through. So you can pause the video, answer the questions, and once you've answered the questions, the answers are on the next slide, so you're going to self-assess. Make sure you've got that green pen. Okay, so check your answers, pause the video whilst you do, use your green pen to correct your mistakes or give yourself a tick if you've got them. These are going to be great revision tools. If you've had to green pen your work, then you can go back and you can see the bits that you just need to revise. Okay, so here's the learning check. You're going to have to pause the video. So pause the video, or you can answer along with me as I speak. So I want to know, does it shift to the left or does it shift to the right? Okay, so which way will this dynamic equilibrium go? Just read the equation so that you know what's there. Okay, so what will happen if you increase the pressure? Will it shift left or right? What will happen if you decrease the pressure? Will it shift left or right? What happens when you increase the temperature? Will it shift left or right? What happens if you decrease the temperature? Will it shift left or will it shift right? What about if you increase the concentration of A? Will it go to the left or will it go to the right? And finally, what if you decrease the concentration of C? Will it go to the left or will it go to the right? You may just want to pause the video here and just check your answers. And now we'll go through them. Okay, so the first one is to the right. If you decrease the pressure, it goes to the left. So if you're decreasing the pressure, you want to increase the pressure, it will go to the side where there's the more molecules, and that's to the left to increase the pressure. If you increase the temperature, it'll turn to the left because delta H is negative. It's an exothermic process, so it's going to favour the endothermic process where it absorbs the energy. So if you decrease the temperature, it will want to increase it. So it will favour the forward direction, the right, and that's the exothermic process. You increase the concentration of A, the system wants to get rid of it, so it is going to make more product. So it's going to send it to the right. And if you decrease the concentration of C, so you're taking the product out, the system's going to want to make more product, so it'll send the equilibrium to the right. Okay, check your answers through. Make sure you understand why they are what they are, and then let's carry on. Okay, so there's some practice questions here. Obviously you can't collect the extension questions, but I have got some extension questions at the end. So take your time working through these. The answers are on the next slide, so pause the video, work out the answers, use your green pen, and then self-assess. Okay, so here are the answers for the previous question. And this is my stretch and challenge question. So this is aimed at levels 7 to 9. So it's looking at yellow iron 3 ions and colourless thiocyanate ions. And they react reversibly. And they form a very dark red iron thiocyanate. So the SCN is the thiocyanate ions. Thio means sulfur, and cyanate is CN. So SCN is the thiocyanate ions, and they're single negatively charged. So we make this iron cyanate complex, which is FeSCN2+, and that is very dark red. Okay, so if you read through, you're going to be looking at how the colour changes, and you need to be able to explain the observations that you see. So 1, 2 and 3 are the observations, and you need to be able to explain each observation. So observation 1, why do you see that? Referring to the equilibria. Similarly with 2, and similarly with 3. Okay, so take about 5 or 6 minutes on this, so pause the video. Once you've done the best you can, the answers are on the next slide. Okay, and I do apologise for the state of these answers. It's a very enlarged clip that I had. Okay, so once you've finished, once you've marked your work, there is a small quiz that I'd like you to do to check your understanding. It gives me feedback. So I hope you've enjoyed today's lesson. I'm looking forward to seeing your feedback from the quiz, and I hope you have a good rest of the day. I'll see you either tomorrow or next week. Bye-bye.